Estamos online.
Mm-hmm.
Do you already showed the first slide?
First slide. We can start with with a presentation first.
I guess someone has the YouTube open, so we have echo here.
Yes.
To what is it due, this echo? Maybe somebody is opening two microphones at the same time.
I think it's the YouTube. Does any of you have the YouTube open?
Now there is no echo. There is echo.
I will just my microphone, maybe. No. I am seeing two Professor Lunes.
Do you think it's him?
You are seeing me?
Yes, that is aí, ó. 1, 2. Yes, Lunes. Tu as une, deux, même 4, je pense. Hein? Il y a 4 écrans avec toi. Il faut que tu...
Alors, attends, je vais quitter.
Oui, parce que à force d'essayer d'entrer, donc...
Alors, je ne sais pas quel est le bon. Peut-être que je vais quitter Firefox.
I will.
Maintenant, je pense que c'est bon.
Okay. And now
I left
it's okay.
Firefox. Is it okay now?
Yes. Now it's okay.
Nice.
But I don't see you, but it's not a problem for me, okay?
Nice is okay.
Nice is okay. I will start. We have online. Boa tarde a todos. Boa tarde a todos. Good afternoon, everyone. And today we have an international speaker, so I'm going to speak a little in Portuguese and a little in English. Welcome, everyone. Sejam muito bem-vindos ao nosso canal do PRH 45 da NP da UFSC. Nós ficamos muito felizes em tê-los aqui conosco para mais uma palestra do ciclo de palestras online do PRH 45. O PRH, que é o Programa de Formação de Recursos Humanos, né, da ANP, para o setor de petróleo, gás natural e biocombustíveis. Eu sou a Tatiana Bendo e sou a pesquisadora visitante do PRH 45 e o professor Júlio Passos é o nosso coordenador. Today we have the pleasure and privilege of having here with us the Professor Lunes Tadrist. Professor Lunes, we thank you so much for your kindness and for taking the time to be here with us today. And I prepared an extract of work trajectory of Professor Lunes. I can read now. I'm going to talk briefly about Professor Lunes' career. Dr. Lunes Tadrist is professor at Aix-Marseille University in France. His research activities focus on energies, energy systems, flows, and heat transfer in multi-phase systems. He started his career at the Scientific National Research Center at research and moved to Aix-Marseille University as professor in 2005. Since 2008, he has been a leader of the laboratory of the Institute of Industrial Thermal Systems in France. He is the coordinator of the interdisciplinary research pole on the energies at Aix-Marseille University. As a researcher at the CNRS, he has developed numerous scientific collaborations at national and international level in the field of flows and heat transfer in polyphasic systems. At the level of European Space Agency, he was coordinator of a topical team on phase change in microgravity and responsible for several projects in microgravity application program. He coordinated several projects with large manufacturers groups such as Renault, Valeo, Nestlé, CNES, ESA, Framatome, Claxtro, and others. In the 2017 to 2019, he was vice president of the ANR Committee, French National Research Agency, and since 2018, he has actively participated in research projects and developed collaboration with research teams at national and international levels. To name a few, Phantom ST Institute, France, Institut Jean Lamour, France, Chinese Academy of Science, China, University of Science and Technology Houari Boumediene, Algeria, Technical University of Dresden, Germany, University of Pisa, UNIP, Italy, and Federal University of Santa Catarina, Brazil, whose partnership with Lab 10 UFSC has lasted more than 10 years. Currently, he has more than 6,000 citations of his works in scientific journals. This is just an extract from the work trajectory of Professor Lunes. Now, before we start the lecture, I would like to remind you that watching us on YouTube, to ask your questions in the chat, that they will be displayed in the end of the presentation. Once again, thank you very much, Professor Lunes. We are ready to hear from you. I will share my screen.
You just
Tatiana,
Yes.
o professor Tadris pediu para autorizar a entrada dele, que ele caiu da sala. Por favor.
Ah, ok.
Pessoal, então, boa tarde a todos, né? Já aproveito para agradecer a todos pela participação. Tivemos um pequeno problema técnico aí, né? Que não foi tão pequeno assim, para ter a ligação completa com a apresentação. And it's a pleasure and a great honor for me to receive today as a speaker, keynoter of our Ciclo de Palestras of the National Agency of Oil, our PRH, number 45 of the ANP. Then it's a great pleasure. Professor Tadristi, as was explained in his short CV by Tatiana, he is a very important person in the ambient of education for engineering education, also as advisor of several PhD students. And Professor Tadristi has also an important role for the development of the science in France and also in other countries of Europe, Africa, and even in Brazil with our very nice cooperation since 2012, maybe. I don't remember exactly, but I know Lunes Tadristi since the beginning of 2000. And it's a big pleasure for me. We have also the participation of Dr. Evandro Rodrigo Dario. He was a former PhD of mine and Lunes Tadristi. Also, Alexandre Bittencourt Dessart, also former PhD student. He spent at least 1 year in France, in Marseille. Now, Alexandre is professor at the Federal Institute of Ibirubá in Rio Grande do Sul, and Evandro Rodrigo Dario in Joinville. Then, thank you very much for your participation. And Tadristi, Lunes, thank you very much for accepting our invitation for this keynote lecture today.
Do you hear me now?
Yes.
Yes.
Thank you very much. Thank you very much, Julio and Tatiana, for this presentation. I am very proud to be with you this afternoon. Here it's late now. It's 6 o'clock. We are almost 6 o'clock. Thank you very much. So before starting my lecture, I want just to introduce myself, to tell you, ladies and gentlemen, that I am speaking to you from Marseille. Maybe you know France, maybe not Marseille. So Marseille, it is a city which is located in south of France, and it is about 800 kilometers from Paris. It's on the coast of France, south coast of France. So here I am. For me, it's a real pleasure to be with you. If it's not the best conditions, as you know, we are not in the best situation due to this pandemic situation. Okay, so I hope that you will appreciate the few messages that I will tell you with this lecture, and I hope that I will share with you this good moment. So I am not able to see the time that I will have to spend, but I will try to be as short as possible to let you to ask me some questions. So I thank again Tatiana and also Julio for this invitation and all the work that you have done to prepare this presentation. So for me, I am at Aix-Marseille University, and this university, I will speak just a few words about the university that I am since 2005. So this university now, it's one of the biggest French university. We have 80,000 students, almost it is 100,000 the total, including the staff and the PhD students and so on. So for me, I am a researcher at IUSTA laboratory, and as Tatiana said before, I am more focused on the energy problems, but also on heat and mass transfer phenomena with phase change. So okay. Now my presentation, go to the first one. To discuss with you the energy issues for sustainable development. As you know, this is very important, and I want to go to the second slide. And in the second slide here, I will try to outline my presentation with an introduction first. Then I will speak about the energy forms and conversion. This is for people who are not familiar.
A moment, Professor. First, I will, if you can see your slides, it's okay.
I can see my slides. Yes, this is the first slide.
First
yes, go
slide?
to the this go to the second slide, please.
Okay.
So the second slide. Okay, is it okay for you now, Tatiana?
Yeah. Yes. Okay. When I share the slide, I the sound of my microphone is off.
Okay.
Okay, but
Okay.
I listen you.
You are listening me. Okay. So thank you very much. So the outline of my presentation, I have 6 points to discuss with you. Of course, the time is short, and I will not be able to go into the details for each one, but just to let you some messages for each of one. So I'm going now to the introduction. Please, the first introduction, and I want to tell you some words about this. And my first slide is about the sun that I am showing you now. Do you see it, Tatiana? Did you go to this slide, please, which is the fourth one? Tatiana, I don't hear you.
Yes, Professor. I listen.
You are listening me. Okay.
Okay.
So I will start my introduction with this nice picture that you see. It's the sun and the eruptions at its surface. With this picture, I wanted to tell you that just one thing to keep in mind is that in 1 hour of the sun that we receive on the Earth, this 1 hour, it gives more energy than humanity consumes in 1 year. This is my first message that I want to tell you. And saying this, you have to believe that the primary energy is abundant on Earth. And we will see that this energy is contained in matter. So the problem is that we don't have we have enough energy, but the challenges that we have are how to convert this energy in a way now that it will be sustainable and environmentally friendly way. This is the most important thing that I want to tell you as in my introduction here. Okay. Again, I want to say some words about this name, energy. What is the definition of energy? And the important point is that the energy, the etymology of this word comes from a Greek word written here, energeia. And the meaning of energeia is that it means that this is a force in action. So we should have in mind this is a mechanical definition of energy. And more generally, it means that it is the capacity to exert a force and to provide a work. In other words, now we enlarge this definition in the way that we can say that energy is the work that a certain force can do. Or in more general words also, it is the ability to perform transformations. It is very important to have this in mind. So the definition of energy at the origin, it is a definition of a mechanical definition. So there is a relationship between a force and also a work. So nowadays it takes a more general definition, but at the origin, energy, it is in this way. It has this definition. Tatiana, go to the next slide, please, which is the 6th one. So for the 6th one, I don't see. I will try to see. Okay. Yes, very nice. So I want to tell you that energy, it's not only, it has not only a technical aspect. It gathers multi-disciplines. So just in few words here that I tried to highlight here, energy has a scientific and technical, it is from scientific point of view, And for science, it has many disciplines in science, technical and humanities, because we have really to have a better knowledge of the forms of energy, sources, storage, but also for humanities. You have the energy laws, the public acceptance, and so on. So it is it is a broad disciplines which gives some connection between all these disciplines if we want really to have a better knowledge and to control all the aspects of energy. This is from scientific point of view, but also from economic point of view, because we have also to define the prices of energy, the taxes, and how we are able to transform this for the future. It is very important from economical point of view. From political point of view, also many countries, they wanted to have energy independence, for example, and also how the public accepts this. We have the problem, for example, in France about nuclear energy. So this is very important from the political point of view. And the last one, but the very important one, it is nowadays, it is from the environmental point of view. So from the environment, we have many aspects from the environment. It is from the local and global pollution, for example, how to manage the waste, how to be friendly with the biodiversity. These are all these aspects are very important for energy. So I want to say here, energy, it's not only linked to one aspect, technical aspect or something like that. It gathers all these aspects which are very important. The next one, this is just to tell you that no, you are going too fast for me. You are going too fast. Come back to the previous one, please. Could you come back to the previous one, please? Tatiana? Yes, thank you very much. So, yes, just a few words about this, just to tell you that this field is a very large field, complex field. And as you can see here, all these are keywords that you can see on this on this picture. The keywords which are used for energy, and you can see that there are too many words with very large definitions that you can see here. You can see, for example, I see biomass, resources, sources, and earth, water, electricity, and so on, systems. So you see that it shows that the field of energy is complex and extensive. This is what I want to say through this slide here. Okay, let me continue for the next one. The next one is for people who don't know too much on energy, and I wanted to say that this is a very important area along the history of humans. And just to tell you that the key dates that I show here, I didn't put too many, but I just put it 3, 4, and then I conclude for something. So these key periods, the first one was when the humans discover and control the fire. It was 400,000 years before, and as they discovered and controlled the fire, this gives to humans a tool to evolve and to have a better life. And what we can explain, for example, for this, when the humans discovered and controlled the fire, they were able to cook to cook and to have some cooking meat and so on, which gives them to reduce the energy consumption for their life, and this gives them much more energy for not having the energy for the digestion what they eat, but they monopolize their energy for the brain, and this gives a new evolution for the humans. This is the first one, discovering the fire, then exploiting the energy of animals for agriculture, for example, 10,000 years before. So you see, it is a long story for the humans, and the changes are not so many during a very long time, you know. So, but what I will tell you now are the changes since 200 years, when the humans discovered the steam engines. So this discovering to 200 years before gives a big change, and we will see this later. And maybe one of the biggest problem that we have since that is that this discovery, of course, improves the life of the humans. But we have another problem, which is a very important problem now, and you know this, is the global warming. So the global warming, it is a very challenging problem. And as I wrote here, this is an unprecedented situation. And we have really in front of us, and for future generation, a very big challenge to overcome this problem, and I will tell you some words. So just in a summary to what I said now, in few words, that nowadays the field of energy is very reactive. There are very big changes in a very short time compared to what happened 1,000 years before. At present, there are very big changes, and we have major changes, and it is difficult to anticipate the problems that we have in front of us. Just to give you some idea, it's the price, but this is not the problem of the future. It's not the price for the future. The future, it's the environment. But just a few years ago, you have seen that the price of the fossil fuels, of oil, for example, it changes by a factor 2, 3, 4 in a very short time. This is very important. So we are in front of a problem which is important for the future, not only for nowadays, but for the future. This is the summary. So please, Tatiana, next one. Okay, what I want just to stress here, again, to say some words for those who are not very familiar, before starting about the energy and speaking in a broad manner on energy, I want just to show you just one or two slides. This is okay, I will not go to this one. Go to the next, please, Tatiana. No, not this one, next one, because I don't have time, you know. I don't have really time to. So now, just yes, thank you very much. This is, I want just to stress on this one about the forms and converters, you know. For just as a general saying here, for the energy, we have several forms of energy. As you can see here, we are 6 basic forms of energy, and we are playing with this in order to use the energy. So these forms of energy are the basic one, and if you really understand these forms of energy, maybe you will be able to manage somehow the technical aspects of the energy. So the 6 forms that I will tell you, there are no other forms of energy. The 6 forms are radiant energy. Excuse me, it is written in French, but I will translate this in English, of course. Chemical energy, but it is also in English for some of them. Mechanical energy, electrical energy, thermal energy, and nuclear energy. As you can see here, we are playing with this now. And if we really understand these forms of energy and the relationship between these energies, we really can control and use the energy in a better way. So as you can see, up to now, we really, for example, we cannot use nuclear energy directly. We have to convert it. And you can see, for example, for this nuclear energy, in order to have final energy, which is electrical energy for nuclear. So we have first to transform this, to convert this to thermal energy, then to mechanical energy, and finally to electrical energy. If you don't do this in this way, you will not be able really to manage the nuclear energy. So the nuclear energy is just the primary energy, but the final energy, it's electrical one. Of course, it's possible also to use the thermal energy for the end use for heating, but it is not usual. There is a real social limitation to go this, because from the technical point of view, it will be better to use it. So this is what I want to say first on this. And what I can tell you also, it is very important to see if it is possible to go straight forward to the final energy. Generally, the final energy that we use, it's the electrical energy. So to go to the electrical energy, it would be nice to have the primary energy, which is for example, the solar energy, to go straight forward to electrical one. But unfortunately, up to now, we have to, in order to produce huge amount of energy that we need, it's not possible to have to have a production of energy in a very easy way up to now. But I think for the future, I think the situation will change, of course. It will change. This is what I want to say through this, this slide. Maybe the next one. Thank you, Tatiana. The next one, excuse me, it is written in French. I was not able to translate it I didn't have time, but it is almost the same message that I wanted to tell you as the previous, but what I want just to add here is that at present, there is one form of energy which is at the heart of all these forms of energy, because we have to manage the thermal energy, because it is a good, an important link between the other forms. Primary energy, for example, I can say the primary energy, which is fossil fuels, it is a chemical energy, and you wanted really to go to electrical or mechanical energy, you have to go through the thermal energy. We are not able to go straight forward from the chemical to mechanical energy. Of course, it is possible to do, but it is limited, for example. But as you can see here, just to tell you that thermal energy, it's a heart as a form of energy and links all the others. This is my message for this one slide. Okay, thank you. So let's go to the next. So now I just said in the first of my talk here, just to tell you, I introduced first, remind you the forms of energy, and we have really to control and to understand all these forms and the link between them. Now I want to go to the third part of my presentation, because the time is going very fast. So just a few words about the energy in society. This is important to tell you some words. I will not go into the details, of course, but I think it's important to have this in mind, the energy in society. The next slide, please. Thank you very much, Tatiana. So this part here, I wanted to tell some words about the energy in human societies. So really to say some words this here. So the final that we humans wanted really is the users, the end energy here, which is the final energy and energy uses. So this is, let's say, important. But I want to tell you that electricity, it is a final energy, but you don't really need as a use. For example, lighting, you use, of course, electricity, but the final, the end energy, it is the light, it is not electricity, and it is very important to know this in a good way. So, but what it is important in my for this slide, we go through first primary energy, and we go to the final energy and the uses. So we cannot go straight forward, so we need converters, as I said before. So we have converters, which are biological converters, but the most usual one are artificial, the converters created by the humans. And this is very important to people who wanted really to have a better control of the energy. They have really to have in mind this energy, primary energy, linked to the final through converters. Otherwise, we are not able to. And from my point of view, the converters it's the most challenging really problem in order to have a good use of the energy. So this is the very important point that I want to stress to you. So converters, they play a very important role. And converters, you should really take into account not only the scientific aspects, but also the technical aspects. So it's very important to have this in mind. Converters, they play a very important role. Okay. So I don't want to go into the details from this slide, but this is just to remind you this fact here. The next one, maybe you go faster. No, you are going faster. Tatiana, could you come back? No, could you come back again? Oh, okay, good. Thank you. Okay, so just to tell you, because I said some words about the energy in human society. You see, just to remind you that to answer to the energy uses, we should have first to take into account the energy sources like fossil fuels, renewable energies, but also converters. But not only this, you see, but also we should take into account the energy vectors like electricity, steam, hydrogen. It's very important to have the energy vectors. And finally, also how to manage the energy from the technical point of view. How you transport, you carry this energy, and how you store it too. It's very important. So you should have all these aspects in order to answer to the energy use. Of course, the final is the energy. Final energy is the energy that we use. But for specialists who have really to produce this, they should have in mind the sources, converters, and also vectors, and the management of this energy. So, thank you. The next slide, please. Now, just to tell you some words about this, which is important for me, and to tell you that we are using a huge amount of energy, huge amount of primary energy, and just to say through this slide here, the total amount of primary energy used all over the world goes to 14,000 millions of ton of equivalent oil, so 14,000. So otherwise it's 40 gigaton of equivalent oil. So it was in 2017. I didn't renew this, but the changes are not too much due to the problems that we have since 2 years now. And I want to say also some other words about this picture here, this slide. You see, since 50 years ago, the amount of energy doubles. It is 2 times since 50 years ago. 2 times, more than 2 times, which is a huge amount, of course. And as you can see here also, we have more than 80% of the energy which is coming from the fossil fuels, coal, oil, and natural gas. If you make the total of this, it is more than 80%. Okay, and the others are nuclear energy, hydropower, biofuels, and also other renewable energy, as you see. So the picture that we have, of course, it is not changing too much since 50 years ago, and this is you should have this in mind. Changing, moving from fossil fuels to renewables, or to non-impacting effect CO2 in the environment, like nuclear power, hydroelectricity, and so on. It is difficult to go to this because the amount of energy that is needed by humans is very huge, and the most important now are still the fossil fuels. And of course, we wanted really to change this for the future, which is obligatory due to the problems that we will have. Okay. Go to the next, please, Tatiana. Okay. Again, to say some other words that we don't know how to use in a good way the energy. As you can see here on this picture, it says many things. First, it says that the primary energy, which is almost 40 billion of ton of equivalent oil, 40 billion. This is the primary energy. And the final energy, it's almost 9 billion. And you can see here from 40 to 9, we lost 5 billion of ton of equivalent oil. So we have lost this. So this means that this loss is not good because it is not efficient, as you can see, and it's a pity that we lose because we are not able to control in a better way. The converters that we use are not so high efficient. That's why we have this result, and we have really to keep this in mind for the future generation we don't have to lose so much. And okay, we will see later. We will see later what to do. The second message that I want to tell you here as the final energy that we use, and you can see here for chemical energy, which is used for transport, it is 33%. The electricity, which is an important final energy and the vector, 17%. And you can see, if you remember what I told you before, the heat, it's a heart of the energy. 50% of the energy is used as a form in heat, So this is very important. These are the two messages that I want to tell you on this slide here. Okay? Let's go to the next, please. Okay. Okay, just to remind for some of you, the energy sources. Now everybody knows this. For energy sources, there are no renewable energies. Fossil fuels, which is a big part of this, but also nuclear, which is a non-renewable energy also. These are, and as you have seen on my picture slide before, a big amount of energy, primary energy comes from this, fossil and nuclear, and the small amount concerns the renewable energy, and we want really to increase this amount of energy. Of course, we will never reach the amount of non-renewable energy from the renewable energy. So this, you should have in mind that we should find solutions for the future, because we will never reach this amount. So the most important thing, and you should have in mind, that we should reduce the energy consumption. Really, this should be really one of the targets that we have. Not to reduce our level life drastically, but we should keep our life level, of course, but using less energy in order to introduce the renewable energy as the main source of energy for the future. Okay, so renewables, as you know, solar energy, hydropower, wind energy, and geothermal energy, but also biomass. It's all these energies are renewables energies. Okay, this is just to show and to remind you this. So, okay, so let me go to the next, please. Maybe I just have to see the time here. The time is going very fast now. The next, what is the next? The next, is it important or not? Okay. Okay, maybe I have to skip this one, Tatiana, please. I will skip also. I will not have time to discuss this point also. Please skip this one again. Okay. This is just a story for you. Okay, for this one, I see. Thank you. Okay, let's skip just 1 or 2 minutes about this one, just to remind. It is written in French, but I want to tell you the story. The story is that in the Middle Age, so the humans at that time, then they don't use fossil fuels. They use renewable energy, and it is mainly wood. So biomass. And the problem that they have at that time, they exploit too much the biomass, and it gives a very dramatic problem for the environment, because forests disappear at that time. And they, as the time is coming to the new age of the steam engine, the humans found the solution to use coal at that time. And the situation, which is a funny story, to save the environment at that time is using coal. And you see, so this was really, it saved the humans at that time in front of the problem of the forest, deforestation. And finally, as you can see now, we don't want really to use coal because it gives another problem, you see. So everything is changing. This is what I told you as a message before. and you should have in mind the problem is very complex. You see. Okay, just for this story, I want to go on for the next. Please, Tatiana. Thank you. Okay, I don't have time to speak on this. It is classical one. Okay, the next one. Okay, just few words about. Okay, where we next one, please. Yes, Tatiana. Thank you very much. Okay. What I want to say here, as you can see, I just have a table here, which shows the main primary energy producers, and you can see, which is logical. You see that we have fossil fuels, nuclear energy, and hydropower, which is the main. When you sum up all this energy all over the world, it corresponds to almost 90% of the energy consumption all over the world. Just to say that on this table you can see the producers, and you can see that the producers, whatever is the fossil fuel, you can see that the countries are coming each time, you say, except for the oil. You see China, United States for the coal, almost more than 60%, they produce the coal. Okay, for oil, which is somehow different, the oil is another story, and it is most concentrated in Gulf Persic, in the Arabic countries, as you can see, Saudi Arabia, but also in United States, but also in Russia. But this is these countries. Natural gas, United States, but also Russian countries. Okay. Then nuclear, you know that nuclear power, United States, untypical France, you see, China also, and Russia. And finally, for the hydropower, we see your country, which appears here, Brazil, you see, but also China, Canada, and United States. You see, the main producers are whatever is the fossil fuels or the energy, they come back again because they are big countries, and they focus a lot of energy in their country. USA, China, but Russia. Okay. This is what I want to say about this. I don't have enough time to speak about in this way. For renewables, maybe I will not have time. I will just maybe say just a few words about solar energy, knowing that we have a lot of renewables. Just to say, okay, please, Tatiana, go to the next, after the next. Go to the next again. Next, please. Yes, thank you. So just a few words just about solar energy, and you can see here the amount of energy that we receive in average. The value that you see here, it's the average all over the year, the amount of energy that we receive and you see that we have in different parts of the world the amount of energy that we receive. And the solar energy is very important as a future use as a renewable energy. So this means that we really should have to improve the technology for using solar energy, because the amount of solar energy that we receive is huge. But we have the problems linked to the renewables, as you know. Using renewables, the amount is not high, it's a dilute, and so on. So I don't have time to speak about this, but maybe if you have some questions after that, I will tell you to answer to your questions about this. So this is the primary energy that we are speaking. Now, if I just want to see what we do with solar energy, please go to the next. The use of energy, and I want just to highlight something with you. So solar energy, to exploit solar energy, you know that it's possible to exploit from thermal solar energy for domestic hot water, but also for housing, to control the temperature in the houses. This is one way of application of solar energy, but also we also wanted to use, it's possible to use solar energy from the thermodynamic point of view to produce the final energy as electricity. So we have really to concentrate this energy, solar energy, and we have several technologies. And the group of Julio is working on this. I think this is very important also way to convert solar energy to produce the electricity. So these are the two ways, but also there is another way to produce energy, which is important, but not very well efficient. But this is the photovoltaic energy. Go to the next, Tatiana, please. I will not speak about the technology, but I want just to tell you that there is a lot of increase of the use of this technology, photovoltaic energy. And up to now, you can see on this picture the cell efficiency versus the time. And the research is improving this in technology. And what you can see at nowadays, the technology of the solar photovoltaic, it is around 15%. You see, it is low, although we use huge amount of panels, photovoltaic panel cells. Although it is low, it is around 50%. You can see here we are at the bottom, the middle. And you can see that from the research point of view, we are able to reach almost 50% now. And I think that this technology in the laboratory, we reach very high conversion from solar energy, radiant energy to electricity. And we hope that this technology will be improved and used from the industrial point of view, not only in the laboratories. And I think photovoltaic will be a very important converter for the future with a very high efficiency. Okay. So I don't want to go into the details about these points because I can speak about wind energy, but I will not have time. About also biomass, I will not have time to discuss this, and it's not possible, and it was not in my in my mind to discuss this because in 40 minutes, 45 minutes, it's not enough. I want just now to go, please. Tatiana, could you go please to the next, after next, and after next to the section 5, please, which is climate change impacts. Go, please. Go again. Continue. Next. Thank you. Thank you very much. Good. So now I want just to my second part of my presentation will be on the climate change impacts. As you can see here, what is the most important thing, because in the past, when we were speaking about energy, we just see the economy of energy because we are focusing on the economy and the price of energy and so on. But this is also nowadays, this is the problem also, the price of energy, because it's important for our life level and so on. But since more than now, let's say 20 years, but the problem was asked in 50 years ago about the climate change. And this is a very important problem which gives rise to the future on the energy, focusing mainly on the climate change impacts. The price will be a secondary point because if the future of humans is not safe, what is the role of the price, you know? So this is just a joke for you, and it is important from my point of view that we have to take into account this. So just a few words about the problem that we have in front of us. It is about CO2 emissions. And you can see that the CO2 emissions here, the total of CO2 emissions, it is about 40 gigatons of CO2. Big part come from the fossil fuels, as you can see here. And the other part, it comes from the land use change, you know, so the agriculture and so on. So you can see, but it is not the highest. The highest one it comes from the fossil fuels, burning the fossils. So on the other side, these 40 gigatons are compensated by the sinks of CO2, but not enough. The oceans, but also the land, and the remaining part, which is very big now, you see, as you can see, the remaining part is in the atmosphere. And this is the problem that we are now having in front of us and for the future. So as you can see, 50% of the global emission remain in the atmosphere. And this is the problem, and it decreases and increases. This is the one important point that I want to stress due to the problem of the energy. Let me go to the next, but just changing this one. As you can see here, I will not have time to detail this. I will speak later on this because the time is going fast. It is just saying that the annual CO2 emission from fossil fuels is very high. You just have to see the previous one and this one, the difference, and it gives you 35 billions of tons of CO2 emitted all over in the world now. As you can see, this situation has never been exist in the past. So this is a big challenge. Okay, what are the consequences of these emissions? Just go to the next, please. The time is going very fast, and I want to say some words about the global warming. You know, thank you very much. The consequences of the global warming. I have two pictures here. The left one shows the temperature, not really the temperature, but the increase of the average temperature, and it goes from a reference. The zero corresponds to I don't remember. It's the average for so many years, and when we compare the temperature, the average this temperature compared to what happens before and what's happening for the future, it remains for a very long time because this is the zero, then minus 0.5 degrees for a very long time, since 1,000 to 2,000 years, 1,000 years before us. Temperatures remains stable and around zero, and it starts to increase. And in 2020, what it is clearly said, it is about 1 and 1.5 degree increase, corresponding to the reference. And now the future depends with these scenarios, and the scenarios, this is due to the increase of CO2, as you can see. The scenarios, they say 1.5 2 degrees, 3 degrees, 5 degrees, depending on the scenarios and depending also on the concentration of the carbon dioxide in the atmosphere. And you can see on the right hand of the picture here, the picture which is on the right hand. So for many centuries, the concentration of CO2 remains almost around 250 ppm. It changes, but it oscillates between 200 and 300 almost. And since now two centuries, there is an increase, and the increase nowadays it is almost 400, 400, excuse me, 400, and depending on the scenarios, in 2100 it might be more than 500 and 550, which is a very huge value. And this is a big problem for the future also. And the global warming, it is the most important problem that we will have for the future. So CO2 concentration and temperature are the main parameters which says that the problem that we will have in the future are these two main parameters, and we don't want really to see the increase of these two parameters. So we have really to take some decisions and to apply, not only taking the decisions, but to apply these decisions. Let's go to the next. Okay, I will not stress too much on this, but I want to say what are the consequences of the global warming. The consequences, of course, as a general saying, they are numerous first and difficult to predict. And the reason of this prediction, this difficulty to predict, it is due to the non-linear effects that we can have. Nobody is able now to predict how the global warming will behave in front of the problems that we will have in the future if we don't take into account, because non-linear effects are very important. But some of them are predictable. These are, you see, I will just list them, but I will not be able to discuss them. The first is rising sea levels. And if this rises, we will have really population which will move from the place where they are now, because a lot of humans are living close to the coast of seas, you know. So this is one problem. The second problem corresponds to the oxygen which is in the ocean, and the consequence is the acidification and the reducing the oxygen in the oceans. So the impact is very huge on the marine life. Okay. The other one is about the heat waves, and we already have this problem in some parts of on the earth, in some continents. Okay. And also the problem is the drought and extreme weathers, and the consequence is about food, the food and security threatened. So this is very important. I will not have time to speak, but you see that the consequences of the global warming could be very huge and very dramatic. So, and there are some others that we don't know how it will be, because we have non-linear effects of this. Please go to the next. So I will speak now a few words about the energy transition. Unfortunately, I will not have time, because it is almost 10 to 7 here. So I have maybe, Tatiana, how many times should I have? 10 minutes more or less? Could you tell me, please? I don't want really to...
I think that 10 minutes or 15 minutes. Okay.
Thank you very much. Thank you very much. So, okay. So I will speak about energy transition and the social challenges. I don't want to repeat this point here, but the social challenges are in front of the global warming and also the natural resources depletion, and the consequences might be very important. Okay. Next, please, Tatiana, next. Okay, now, good. This is good for me. Good. Okay. Through this picture slide here, I want to tell you some words which are important from my point of view. So as you can see here on these pictures, we see the variation of several of three parameters. These three parameters, important parameters and variables, are population over time, since the beginning of the industrial revolution, 18th century, you know. So as you can see here, I showed the population on the top one. Then down here we have the global primary energy consumption, which is down right, and down left it is annual CO2 emission. I showed this before. So as you can see, the message that I want to tell you here, since 18th century, this means industrial revolution, these variables, which are very important for the humans and for the environment, they grow exponentially. And the question that we have to ask and to try to answer, could we really, for the humans and our planet, could our planet support this problem with the increase exponentially for the population, but also for the CO2 emissions? I let you answering to this question because from my point of view, an exponential growth of these quantities lead to a really very complicated situation for the future. I said here, this is unprecedented situation. So we really have to think. When I say we, I mean humans. They have really to keep in mind it's not possible to continue in this way, and otherwise we will have climate deregulation, and climate deregulation means that problems for the future. The most important thing that I want to say, faced to this emergency, many scenarios have been proposed, and I am not able, unfortunately, to detail these scenarios, but I want just to tell you that these scenarios, we see that many scenarios, they are converging to one and the same thing, the same goal. So the scenarios which were proposed, they are proposed by agencies, but also some companies. Agencies, it's an international energy agency, which is well known, but also in France, for example, we have our national agency on energy and the environment, but also we have another company, which is ENGIE. They produce energy, electricity, and also gas energy. They have scenarios, and the scenario, it says the same thing. They propose a significant reduction of CO2 emission until one objective is to reach the neutrality in 2050. Why this? It is because mainly to these curves that I showed you. Because the consequence of this, if we continue to grow exponentially, the temperature that I showed, the increase of the temperature, it will not be 2 degrees. It will be 3, 4, 5. And you can see the consequences. So we should really have in mind this. Please keep in mind this. These exponential variations of population and also fossil fuel consumption, but also the CO2 emissions, it's not possible to continue without that dramatic issue. No. So we should really go to this goal to achieve the neutrality, carbon neutrality in 2050. This is one of the important messages that I want to tell you. Okay. Okay. This is I want to go to the next, maybe to the next. Next. Okay. So thank you very much. Energy transition. So this is very important. This is a very important thing that I want to tell you about energy transition. Okay, so for the energy transition here, just a few words about the energy transition. For the energy transition, so let's first define energy transition. What does it mean, please? So the meaning of energy transition is to go from the current energy system that we use to, which is non-renewable resources, to renewable resources. So it is important to replace fossils and nuclear fuels from the theoretical point of view, let's say, by renewable energy sources for all the activities. So this is very important. As you can see here on this picture that I show you here, you know that the use of fossils, it is just a peak in the life of humans. So just, let's say, few centuries, no more, no more. We already used 2 centuries. We don't know how many centuries, and the problem is not really using fossil fuels and there will be a lack of fossil fuels. No, the problem is linked to the climate change now. So we should really go to renewables energies, although it is difficult. So we really should think about this, and we have to apply and to reduce our fossil fuels consumption. So this is the most important thing that I want to tell you about energy transition. So what are the challenges now? What are the challenges of energy transition? The challenges are, I just listed here, and I will not be able to explain every. So the most important thing that about the energy transition, maybe for me, among all these points, is to reduce the energy consumption. So this means that we have really to have energy efficiency because this will lead to many advantages, as you can imagine, and really it is urgent to do this. Okay, not only speaking about the independence of energy, I think it's not enough. It is really in front of the impact of climate change. This is very important. I think this is the most important thing nowadays. Okay, please, could you, Tatiana, go again? Continue, please. Continue. Okay, thank you very much. So, just to tell you a few words about the energy transition again, then I will conclude because it's okay for me. You see, so just to tell you that for energy transition, when we were speaking about energy transition 10 years ago, some countries they take some legislation to ensure the energy transition, because they produce laws on energy in order really to have energy transition to reduce the CO2 emission and so on. But I will just take one or two examples, and you can see the message that I want to tell before is that we don't have countries that don't have the same objectives, and this is one complicated story to reduce CO2 emission, you know. But this was 10 years ago. You see, for example, I can tell you, I will take you just 2 or 3 examples because I don't have enough time. For example, there is no law on energy in United States, but they have priorities, and I can just tell you that these priorities, just to list them, the most important priority for United States a few years ago, and it still remains, I think, it is the energy independence. It's not, it has no, it is not the first priority, the second or the third one. The fourth priority was about climate change and greenhouse gases reduction, but it is not the first one. You see? So this is an example for United States. I can say also something else about Germany. They produce a law on energy in 2011, you see, 10 years ago, and they took really strong decisions. For example, they decided really to develop renewables energy, and the target was 35% of the energy that you use will be from renewables in 2020. And in 2050, 80%. You see, this was 10 years ago. And this is very important for them because it is for them important really to use renewables. And in addition to this, they really work on the energy efficiency. So the reduction of energy demand, they have also targets which are very huge to reduce by 20% the energy demand and by 80% in 2050. You see, so they have really very big challenges and to fit with renewables in 2050. But you know, they apply this, but you know that they use a lot of coal at present because they are closing their nuclear power because of Fukushima. They shorten the time to stop the nuclear energy. They are destroying all their nuclear powers. This is, and they replace this not by renewables but coal, because renewables are not enough nowadays. You see, so but they have really a strategy to use renewables for the future. So I will not have time to detail this, and also for France, it is the same, but the objectives of the law that we produced in France was really, it was in 2015. So and this law, it was not really a strong law in front of the reduction of greenhouse effect and CO2 emission. They just have some objectives, but not really, how to say, very saying that the objective is to reduce by 20, 30, 40% the CO2 and so on. No, they are just general saying. This is what they call titles. So they are saying better, for example, better renovation of buildings and so on. But they don't say how many, what are the objectives? Because, for example, in France, the primary energy that we use for building, it is 43% of the energy that we use in the primary energy. Among all the energy that we have, 43% is devoted for heating buildings. So you see, but they don't give how they have to reduce and the objective that we have to reach. Just to say we'll have to lower and so on. Okay. So this is the big challenges that we have, and what I want to say here, that in these cases that I showed, we can see that the legislation has not been effective in ensuring an energy transition. You see, for these three cases, we are too far from reaching this objective in front of the emission reduction. So what I want to say is that the situation remains really complex, and much more directive legislation should be undertaken in order to reach these objectives. This is what I want to say. And the second point is that although we have objective for each country, the problem is more general. And really, we should take decisions at the level, not countries, but at the level of all the countries. So you see, this is a very big challenge. And for example, for the last conference of the parties, COP, they didn't have a common decision because they have two divergent, let's say, objectives, because they have to answer to the demand of each country, and the demands are different from one country to another. But we have an emergency for the climate, which is one of the most important objectives. Okay. How time is it? It is now. I will maybe just go to the conclusion. Please, could you go to the conclusions, please, Tatiana? Okay. Just to conclude here, and you understood that I just wanted to say just from main keywords about the problem that we have in front. First, using energy, we use matter, and they are intimately linked. So using energy, you are using matter because you are converting this matter to energy, and it is very important. This is the first point that I want to say, because we have to save matter, but we have also to save energy. This is the first point. The second point that I want to stress is that we are in front of big challenges for humanity, and these big challenges, they are also urgent in front of the climate change. This is the second point. My third point is that if we want really to have a better control and managing the energy in front of the problem that we have, is that we have to promote a multidisciplinary approach. A multidisciplinary approach, we know that this is the only way really to answer to the challenges that we have. Okay, an important point also that I want to stress is that for the future, we should really have a paradigm shift using energy, and because with the challenges that we have are very high, and only a paradigm shift should answer to this problem. So I can say some words, but I don't have enough time about this. So the other point that I want to stress, it is linked also to the previous one. We should really promote a holistic approach. A holistic approach means for me that we really have an approach which should take into account all the aspects of energy in order to meet these challenges again. Okay, I think that this is my final slide, and I want to thank you all to what I said. I hope that I was clear, not really enough probably, but I am open for questions if you have, please. Thank you very much again, and excuse me for the beginning. I was late and I have some difficulties to send you my file. Thank you very much.
Thank you, Lunesta Dristi, for very nice and interesting talk.
Thank you very much.
Tatiana.
Thank you, Professor. Thank you for the excellent lecture.
Thank you.
I'm sure that many more people will watch this important lecture in our channel. Thank you again.
Thank you very much, Tatiana. Thank you, Professor Passos. Thank you, Julio. Thank you.
Do you have
Thank you for the audience also. I don't know how many people follow this presentation, but thank you for the audience, of course.
We have some questions in the chat. I can put the questions in the screen.
Thank you. Yes, please.
Okay. The first.
Okay. Thank you very much, Felipe. The perspective of the future of PV energy generation. Okay, this is what my slide that I showed before. I think that PV will be one of the important converter of energy to produce electricity. I think that nowadays the efficiency is about 15%. I think that for the future, using this multi-cell junction will really allow us to improve the efficiency. And I think that step by step we will reach higher efficiencies. I remember 40 years ago, for the PV, the efficiency was about 5%. And the people, they didn't really focus using PV. And since 20 years, a huge number of researchers are working on PV materials. And I think that the improvement will be for the future and the efficiency will increase. And my wish is that research will save us and will give us a very high efficient PV. So the generation for the future, I think multiple junction will be one of the way to increase, to have higher efficiency. I don't hear you, Julio.
Tatiana, do you have more questions?
No, in the chat we don't have, but I have a question. My question, Professor, is if the solar energy technology available today is sufficient in theory, in practice, to supply or provide our planet's current energy demand.
Tatiana, could you please repeat? I didn't hear well your question, please.
Okay, I'll trying to pronunciate very well.
No, I didn't really catch what I didn't hear well. Please.
Okay, if the solar energy technology available today is sufficient in theory, in practice, to supply or provide our planet's current energy demand.
Okay. Solar energy. For me, if really want to use solar energy, we should really do a first thing. It's really to use the energy in an efficient way. I mean that, as you can see, the solar energy, the amount of solar energy, of course, it's possible to produce much more solar energy, but the amount that we are able to produce will not be comparable to the energy of fossil fuels and so on. So the only way really to remove the fossil fuels and use renewables, and solar energy is one of the renewables, of course, is really to have an energy efficiency. For example, I can tell you, yes, in other words, I can tell you, for example, using the energy in buildings, we use a big amount of energy in buildings, for example, in France for heating, okay? Air conditionings in China, maybe also in Brazil and so on, okay? And we use a lot of energy, and one way really to reduce the use of this energy, whatever it is, okay, we really should have a better insulating building and using the energy in the building in such a way that the building, in order to be consumers of energy, they will produce the energy. And in this way, really, the solar energy could really be a good way to use for the humans, and to have a good use of solar energy and efficient energy. Did I answer to your question?
Okay, thank you, Professor. Thank you.
Thank you, Tatiana.
If I can take a part in the answer to Tatiana also, a main problem for using solar energy is the storage of energy. Then is a very big challenge of our humanity for guaranteeing energy for all of our societies, and at the same time protect the environmental. I can talk also about a slide presented by Lunes, showing that 35% of the primary energy, that it was close to 13.7 gigaton of oil equivalent, 35% is lost when we regard the final energy, because only 80.9 giga-TOE is utilized. Then we have a very big challenge, as was very well presented by Lunes. First of all, for guaranteeing energy. Secondly, protect the environmental. But in order to use solar energy, wind energy, and all of other renewable energy, we need to develop more the capacity of storage. If you can talk more about this, at least it will be interesting also for us.
Yes, thank you very much. Thank you very much, Julio, for your question. Of course, the renewables, they need really. There are two main weaknesses. The first is it is dilute energy, solar energy or wind energy. It's dilute, and also intermittent. So the intermittency and the dilute should really solved through the problem of how to say storage. Of course, the storage is one of the key points, from my point of view, the key point to use in a very broad way the renewables. So now the storage, it's not so easy problem. I think that everybody knows that the problem of storage is the, how to say, is one of the challenging problem for renewables. But from my point of view, this problem could be really solved when using small amount of energy, because with a small amount of energy, we have techniques to store, of course, batteries, but to store energy in a huge way, I don't know technical today. The only way that we are able to store energy with a big amount is using hydraulic, steps, the steps. But storing energy in a way of electricity in batteries and so on, it should be a small amount, but using in an efficient way the energy, I think that we can solve this problem in some way. We can solve this problem, but the most important thing for the future, from my point of view, is really to develop research in this field of storage. Batteries, for example, today, that batteries, I know this since a long time, before the age of lithium-ion battery, there was no solution to store energy, to have how to say, cars, electric cars, and so on, but now this problem was partly solved, producing materials which allows us to store much more electrical energy. And I think that there are some technologies for the future. I heard, for example, storing energy, electrical energy for cars. We are able now, for example, to have cars for which batteries allows to have 500 kilometers instead of 200. I have an electric car. I have just for 250 kilometers, but now the new one are 500. But this is always with the same technology, lithium-ion technology. But there are all other technologies which allows maybe for the future with research to have cars with autonomy of 1,000 kilometers. Reducing the size and the compactness, it will be possible, I think. So I believe in research that we will really improve this problem of storage of energy.
Thank you, Professor. We have more question in the chat. I put on screen.
Thank you. Thank you very much, Harrison. Thank you for your nice question. About the thermal energy storage, just a joke for you, Harrison. This was my first topic research when I was a PhD student. The challenge was for me, are we able to store energy, thermal energy for the applications, several applications? And I believe yes, of course, thermal energy storage might have some applications. So I think we are not able to have application in a very large way. So, for example, to store energy for producing electricity with thermal energy storage, I think that it is nowadays it's a big problem because we don't have efficient materials in which we are able to store a huge amount of thermal energy. This is, I think, the limitation of thermal energy storage is due to the materials. And I know, for example, when I was working on this topic, I was working with molten salts. And molten salts, they are used for application in a solar power plant in Spain, and I think that molten salts are very good materials, but the amount of energy stored in these materials needs a very huge amount of salts. If really there will be some issues with thermal energy storage, from my point of view, we should really produce new materials able to store much more energy. I think this is one issue, this is one issue. But what I can say is that for some applications, limited applications, thermal energy storage, it's important, It's very important. It exists. It exists already, for example, storing heat in water, for example, for house applications. This is the usual. But for producing electricity, it needs really a new step.
Can I make a question? Do you hear me?
Yes, Alexander.
Yes.
It's not really a question. It's more a comment. I want to know your opinion about on this topic of cars, electric cars. I was reading a text from a student, and he was showing that the energy consumption in Brazil for the year of 2020 was around 33% oil, but all energy, including cars and the mobile part, and only 12% of hydric power. And when we come to the electric matrix of Brazil, we have 65% of hydraulic power generation. So you think it's a viable solution, like using this battery like you have on the United States for Tesla, so we can have renewable in exchange for oil for this mobile part mobility? I think it's
yes. Thank you very much, Alexandre, for your question. My answer is not so. I am not able to answer you in a very easy way. Because, for example, this is a big question in Europe. Let's say in Europe, and I will try to answer. Maybe you will find the answer through my to your question through my answer, but I will try to take the case in Europe. For example, we decided in Europe that in 2035, no thermal engines. All the engines will be electrical. Okay, and I made a calculation. How many electricity do we need? Power plants do we need if we replace the thermal engines cars by electrical cars? Yes. And I computed this, and I found that we have to have a twice park of nuclear power plants. In France we have 60. There's not power plants, but nuclear reactors. 60. Okay. If we want really to move to electric cars, all the cars will be electrical, we should have 120 nuclear reactors to double, which is a huge, of course. And I don't believe really that we will have cars. All the cars will be electrical in 15 years. I don't believe in that. So probably in Brazil, I don't know how many cars you have. You have just to make a compute and to see how many electricity do we need. Do you need to do that? You know, just a rough calculation you will see. I don't know. I am not able to answer you, but we need a lot of electric power plants to use in order to fill with electricity the batteries of cars.
Yeah, in our advantage, we have a lot of rivers and this hydric potential, but nevertheless, we have to build several more power plants. In the region where I'm working now, we have a lot of this small hydric power plant.
Ah, yes.
Okay. They have a lot of potential for that. But
and
I remember the electric bill from France. It showed how much of the electricity was produced by nuclear power. It was around 80-90%. It's really.
Yes. Do you know this application? We have an application. I told you about this application when you were here? Okay. You know, I can show you this. I have on my mobile an application for which we are able to see at each time, okay, what amount of electricity we produce and what amount of electricity that we use and what is the source of energy coming from, you know. I will show you this. Just I hope I will tell you. I don't know if you have this in Brazil, but it is a very interesting application. Do you see it? Okay. Okay, I will show you.
Yeah, it's a little bright, but I can.
Okay. Okay, I will show you. I will show you. Did you see this? I am not able. It is.
It's too bright.
I don't know why. I don't know. Yes. Okay. Let me.
But we had a seminar a couple of weeks ago, and in Brazil, we're going to have some laws changing about the production and selling energy. So the user can be a seller of energy. So I can produce in my home and sell it. I think this will facilitate people to migrate to renewable energies. You think it's a good solution for the future?
I believe that yes. In what I believe, yes. More generally, in what I believe is that the energy, the way. This is one of the paradigm that I wanted to stress. The way that we are producing energy now is the way that we are producing intensively the energy through the power plants. Okay. And we distribute, and this is not efficient way. And I believe that it is important to produce the energy at the place where you use it, you know. So this means it goes to the idea that you are telling me. So to be your own producer and selling to, you know. So this is, I think, the only problem is really we should have energy storage and also the techniques to storage and also to manage the electricity. To, you know, smart networks should be, you know, because, for example, in Europe here, the problem that we have using renewable energy, wind energy, you know, for example, in Germany, they have a lot of wind energy, and as they have time where they produce huge amount, you know, but it is intermittent energy, and this leads to have the net of electricity not stabilized. There are a lot of fluctuation, and we have a big problems with this. You know, it disturbs a lot. So really, we should really produce smart network in order to use the intermittent energy coming and so on. This is the big challenge that we have.
Yeah, I guess here we are marching towards this, the smart grid.
Smart grid, exactly,
Yes.
smart grid. Yes.
So the problem we have now, we were having a dry season, so even the hydro power plants were oscillating. So to stabilize, we have to put our coal power plants to work. So
Yes,
and there was a couple of coal power plants in my hometown that they were about to be deutilized. I don't know, dismantled, and they were from Engie. But we can't do that with coal power plants in Brazil yet because we have this energy problem. We have a shortage of energy when we have these dry seasons because we rely mostly on the hydric power.
Yes, this is a big question. This is a very big question, I guess. And the solution to this problem, is really to have a good way to use the energy in such a way it should be energy efficiency. For example, I explained to my student, we should not continue using energy in the same way that we have done this since not century or more. We should really think about a new way to use to produce energy and to use the energy. The most important example that I gave to my student is for buildings. We can really, if you manage in a good way the energy in the building, instead of being consumer, you will be a producer. But this needs really a very high technology. For example, here in France, they improved the quality of life in buildings because they just insulated in much better way, and they managed the fluids in the building in a better way. So many people, they were telling me in the new building, in their flat, their new flat, they don't really consume too much energy. The amount, the bill that they have to pay for the energy was reducing a lot, maybe 2 or 3 times. So this is the way. I think the future for the energy is this way, reducing a big amount of energy with a higher technology. So we have really to have a better control and the management of the energy, I think.
Yeah, thank you. As always great to speak with you. I just
Thank
have
you
one small curiosity about something you showed on the slide. Then I guess we already passed the time from this presentation. But when you and Professor Passos were talking about how much of this thermal energy was lost, something about that. This is lost above the second law. This doesn't count with the heat sinks, or this is the part that is lost plus the second law?
Yes, you are right. Yes, this is the one part comes from the second law, and the other part is losing the matter, oil and so on. But the second law plays a very important role. Yes, you are right.
So there's a part we can't use that part. It's already going to be lost.
Yes, exactly. So that's why we should change the way that we use the energy. For example, I can tell you one more example before maybe ending our discussion. For example, we in France, that we have a lot of power plants. Okay, the amount that we use, I can show. I'm not able to show you this because it's not possible to share with you. But in France, for example, we use the equivalent for power plant, nuclear power plant, almost 35% of the primary energy is from nuclear. 1/3 of the total energy that we use in France. We have almost 100. The total energy that we use in France is 278 million of ton equivalent oil. 278. Okay. From the nuclear power plant, it is more than 100. Okay. And the final electrical energy that we produce, it's 1/3 of this. 1/3. The 2/3 are lost due to the thermodynamic law. Okay. But in France, we choose to don't use the heat release. But if we use the heat which is released for buildings and so on, you know how much we save as energy saving? It is a big amount. So I think that we can really reduce the amount of the energy consuming due to this the lost part due to the second law, thermodynamic law, just by using in a smart way the energy, not only using, for example, the electricity, but also the heat.
Perfect. Yes.
Okay.
Thank you.
Thank you very much.
Thank you,
Thank you,
Professor. Thank you very much.
I just saw another question from Fernando Santos. It's about these laws we are making that's going to change in Brazil. We have mechanical engineering seminary from where I teach, and we had a person that works with these smart grids and with hydric power plants, and he told it better. So I'm going to put the link from this seminar on the chat.
Okay.
So Fernando can watch this later. I'm not really sure what laws are going to change. I just participated of this seminar, but on the seminar they specify everything that's going to change in the next years, and how the producer, the user, can produce and sell energy. So this will be really incentivized here in Brazil.
Very nice initiative. Very nice initiative.
Thank you once again, Professor.
Thank you very much. I was very happy to talk with you, Alexander. Happy to exchange with Tatiana that I don't know before. But Julio he left maybe.
He had a medical appointment.
Oh.
Okay. So thank you very much again, and hope to see you. I don't know, in France or in Brazil. I hope.
Hopefully in France.
Evandro, you appear. Thank you very much, Evandro. I hope that I will meet you in the near future, Evandro.
Moi aussi.
Merci beaucoup. Thank you again. Thank you for all of you.
Thank you, Professor. Thank you again. Bye. Thanks to everyone who watching us in YouTube, and see you the next time.
Thank you. Bye.
Thank you, Professor.
Thank you very much, Tatiana.